Hi everyone, welcome back to my channel on data engineering. In today's video, we'll be looking at a project called Lore Insights. This project is done with SQL. Let's start. So there is a company called Easy Loan, which offers a wide range of loan services to its clients, say from personal loans, car loans, and mortgages. They offer these services in Canada, United States, and the United Kingdom. Now, coming to the database schema here, we use a lending database here. And in this database, we have four different tables, and they are connected on their primary keys. We have a loan table, we have client, contract, and repayment tables. So now, coming to the first task, here the analytics team wants to use the clients table to create a dashboard for the client details. So they want to make sure that the data is proper, and the analytics team expects the data types and formats to be with the description provided here. So here we are given the clients table information and the relevant data types. So we need to write a query such that the clients table match with the description provided here. I've written a select statement and it returns the client ID, which is unique and it's the primary key. And coming to the date of birth, here I have used two-day, two-care. So I'll explain this. Date of birth and timestamp, year, month, date. So this converts the date of birth to a timestamp data type. And then this toChar is used to convert this timestamp data type to a string in the form of year, month, and date. And then the outer toDate function is used to convert back the formatted string into a data type. And this complete thing is aliased as date of birth. Here, for the employment status, I'm using a case statement. And also, it should be in lowercase string. So I'm using a function lower. So here, when the employment status is unemployed, then it returns unemployed. Else, it will return employed. And I'm ending this case statement with employment status as the column name. And here you can see the country of the clients, and it should be in the uppercase string. So I'm using an upper country here so that it returns uh, all the uppercase strings as you can see here in the query result. So yeah, this is the first task. So we are just matching the column names with the given description. Yeah. Moving on to the second task here, the analytics team has found out that there were some missing values in the repayment channel. So here the repayment channel is nothing but the mode of payment that you do, that is through mail or through bank account or through debit card or through credit card. So here to find out the missing values, I have written a query. So luckily, the team have discovered a pattern for the missing values. So they say that when the repayment amount is higher than $4,000, it should be made by a bank account. And when the repayment amount is lower than $1,000, it should be made by a mail. So you can see that I have written a query so that the respective columns are being returned in the query result. I have selected the loan ID, repayment date, and the repayment amount. So here I am also selecting the repayment channel, but I'm writing a case statement for that. So here I'll just run it so that it will be easy to understand. So as you can see here, I have written the case statement here for the given condition. So it says when the repayment amount is greater than $4,000, then it should return account. And when the repayment amount is less than $1,000, it should return as mail. And I'm ending this as a repayment channel. So as you can see here, when I run this query, so yeah, just it takes a bit time. Yeah. So you can see here when the repayment amount is less than $1,000, you can see the repayment channel is in mail, and you can see an example of, yeah, here. So if you see the repayment amount is greater than $4,000, it returns bank account. So as per this, we can say that the given condition is met. So you can see null values returned for the remaining repayment channel amounts, like for the amount which is between $1,000 and $4,000. So to return the mode of payment that is done for the amounts between 1,000 and $4,000, I'll just write an else statement, uh, and I'll return it as repayment channel so that you can see the mode of uh, repayment channels that is done. So now if I run this query, you can see, yeah, the amounts which are between 1,000 and $4,000 are being returned here, and the mode of repayment channel is also being returned. So now coming to the third task, the analytics team here wants to analyze the loans for US clients, whoever has upgraded to a new online system, and it should be from Jan 1st, 2022. And these are the four columns that needs to be returned in the query result: the client ID, contract date, principal amount, and the loan type. So as you can see here, I have returned the query. I am selecting the client ID from the client table. I'm selecting the contract date from the contract table, the principal amount from the loan table, and the loan type as well from the loan table. So here I have to join the loan table with the client as well as the contract tables, because we need to get the client information and the contract date, because we were asked to query the contract date. So we need to join these two tables with their primary keys. So I'm joining loan as I'm aliasing it as L, and I'm joining it with the client table and aliasing it as C. So I'm joining on their client IDs since they are the primary keys. And I'm also joining the contract as CT on their, again, on their primary keys. Using the where filter to filter out the contract date from Jan 1st, 2022, as given in the question. And I'm also filtering the country, USA, because we were asked from all the US clients. Yeah. So this is the query, and this is the query result that you get. I'll just show this as well. So this is the query. Here I've added country as well. So just for your understanding. So if I run this query, yeah, you can see the query result. So this is the client ID, this is the contract date, the principal amount, loan type, and the country. On to the final task, it's given that the business strategy team is considering offering a more competitive rate in the US market. And here the analytical team wants to compare the average interest rates offered by the company for the same loan type to in different countries in order to find if there is any significant difference. And so for that, we'll be writing a query and we'll be returning the data to the analytics team. And it's given that the output should include loan type, country, average rate, columns. So this is the schema that we know. Let's look at the query. So here I have written a select statement which selects the loan type, country, and average rate. So to find out the average rate, I'll be selecting the interest rate column from the loan table. So here, why I'm selecting this interest rate? Because to find out the interest across different countries for the same loan type. So I'm considering picking up the interest rate column here. And from loan as L, so here I'm taking the loan table and aliasing it as L. I'll be joining this with the client table since we need the client's information. And I'll be joining it on the client ID since client ID is the primary key. Here I'm grouping by loan type and country because this groups the results by each unique combination of loans and with each country. And by grouping in this way, we can calculate the average interest rate for each specific loan type within the country. And finally, I'll be ordering by loan type and country again. So this sorts the final output by loan type and then by country in ascending order. For the same loan type and in different country, you get the average rate. And you can see that the loan type country are in ascending order. So yeah, this is the end of the project. If you have any doubts, please post your questions in the comment section. I'll be answering your doubts over there. If you like the video, please share and subscribe to my channel. Thank you for watching the video.